Hello, everyone. This is going to be part 3 of the Chapter 9 Examples of Rigor video series. So this is Target C, simplifying and solving radical expressions and radical equations, okay? So we're going to start by just simplifying expressions one by one. Feel free to pause at any time, and then we'll slowly work our way into solving equations, okay? So if you look for number 10, we need to rewrite the radical by extracting all possible roots, assume the variables are positive, and write your final answer in radical form. Okay, so what we're going to do for part A is I'm going to start and I'm going to break this down. So I'm going to say 40 is 8 times 5. I know 8 is 4 times 2 times 5. I know 4 is 2, 2, 2, and a 5. So if I break down that 40, I have 3 2s and a 5. And I also have 5 A's, 1, 2, 3, 4, 5, 2 B's, and a C. Okay, and that is all inside my square root. Now, because it's a square root, I'm looking for groups of 2. Okay, so if you do this, I have a group of 2 2's, I have a group of 2 A's, I have a group of 2 A's, and I have a group of 2 B's. All right, so if I try to reduce this radical, what I can do is I can take a 2 out front, because I had a group of 2's. I had 2 groups of A's. I had one group of B's, and then inside my radical, I still have a 2 and a 5. Now you can put those values back together. So if you have both a 2 and a 5 still inside, you can put those back together and we multiply them to be 10. And then I still have an A and I still have a C. And this would be my answer. Okay? So let's take a look at B. Now this one is a little different because it's a cube root. It's not a square root, it's a cube root. So if I do this, let's break down 16. I'm going to say 8 times 2, 4 times 2 times 2. This is 2 times 2, a lot of 2's here. So 16 is just 2 4 times. I have 7 x's, 2, 3, 4, 5, 6, 7, and 9 y's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I take the cube root of this, okay, I want to circle not groups of 2, but I want to circle groups of 3. Okay, so what I'm going to do is I'm going to circle. I have a group of 3 2's. I have a group of 3 x's. I have another group of 3 x's. I have a group of 3 y's. I have another group of 3 y's, and I actually have a third group of 3 y's. Okay, so let's see what we got here. So my answer, I had a group of 2's. I had 2 groups of x's. I had 3 groups of y's. And then on the inside of my cube root, I had still a 2 and an x. And this would be my final answer. Okay? Let's take a look at part C. So now I have a 4th root. So I don't want to use groups of 2. I don't want to use groups of 3. I want to use groups of 4. So if I have a 4th root, I'm going to break 256 down. Now here's where you might need a calculator. Okay? I'm going to kind of break this down the best I can here. I'm going to say, let's see here. I have 2 and 128. And then I have the same 2 and 128 is going to break down to 2 and 64. I think I'm going to get a lot of 2's here. So 64 is 8 times 8. 2, this is 4 times 2. 4 times 2. So I think I'm going to get an enormous amount of 2's here. 2. So how many 2's did I get? I got 2, 4, 6, 8 different 2's. So 256 is actually 2 to the 8th power. Okay? So what I'm going to do is I'm going to write this out. So I have the 4th root. Okay? And I had 1, 2, 3, 4, 5, 6, 7, 8 2's. I have 3 m's, and I have 7 n's. Let's see if I can do this here. I'm worried about fitting it in this space. 1, 2, 3, 4, 5, 6, 7 n's. Right? Okay, so now let's circle our groups. Now we're circling groups of 4. So I have 1, 2 groups of 4 2's. I do not have enough m's. I only have 3 m's. I need a group of 4, so those have to stay inside. But if I look at the n's, I can circle one group of 4 n's. So if I do this, I can actually take out 2 groups of 2's. I can take out one group of n's. And then I have the 4th root of still 3 m's on the inside and 3 n's on the inside. Now, I would probably write my final answer here as 4n, because 2 squared is 4, times the 4th root of m cubed, n cubed. And this would be my final answer. Okay? Now, on to part D. I'm back to a square root, right? So let's go back to the beginning, right? Square roots, I only need groups of 2. So if I break down 36 into 6 times 6, 2 times 3, 2 times 3, right? And then I have a B, I have 5 C's, and I have 3 D's, right? And I'm going to take the square root of that answer, right? Now, if you look, I have 2 2's and I have 2 3's. Maybe I should write that in order for everyone. So I have a 2, a 2, a 3, a 3, a B, right? Let's get my pen working here. C, 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 4, 5, and then 3 D's. So if I take the square root of this, I have a group of 2 2's, I have a group of 2 3's, C, another group of 2 C's, a group of 2 D's, right? So I can take a 2 out, I can take a 3 out, I can take 2 C's, and a D all come out of that radical. Now, what's in that radical? That's the question. So I have, it looks like I still have one lonely B, I have one lonely C, and I have one D left. So if I put this back together, I would write this answer as a 6 C squared D times the square root of B C D. Okay? And that would be my answer. All right, so that is reducing radical expressions. Okay? Now, if you take a look at number 11, it says write the expression that simplifies to 3x times the square root of 2xy. So let's say I want to work backwards, right? Let's say I want to know what the original problem was. That's what this question is asking, right? If you did this, right, this is a square root. So what I have here, if I want to work backwards, if there's a 3 on the outside, that means there had to be 2 3's on the inside. Let me write that a little bit more neat. It's a little messy. Let's get this a little better here so people can read it. So again, if there's a 3 on the outside, that means originally there had to be 2 3's on the inside. Okay, now there's still a 2. Now, if there's an X on the outside, there had to be 2 more X's on the inside, and there's already 1 there. And then there's a Y on the inside. So if I put this all together and I multiply all that together, again, multiplying it all together, 3 times 3 times 2, 3 times 3 is 9, times 2, I'm going to have the square root of 18, x to the third, y. This would have had to been the original problem in order to get that expression. Okay, so write an expression that simplifies to that means what was the original problem before you simplified. Okay, for our purposes, you do not have to worry about 12 and 13. You can skip those. I'm not going to have you translate from rational exponents to radicals and vice versa. Okay, now we need to get to operations. So we just reduced radicals. So now we're going to perform operations. So addition, subtraction, multiplication, division, all of those things. So what I'm going to do here is for part A, I have the cube root of 64x, and I'm going to multiply that by these two things. So what I want to do, hang on. So what I want to do is I want to distribute into the inside. However, if I distribute into the inside here, these are going to become very, very large numbers. So it might be in my best interest to try to reduce these radicals ahead of time. So if you were to take 64 and you do the cube root of 64, you can do that on a calculator. You can break it down into different pieces. But the cube root of 64 is just 4. Cube root. Now you can't reduce the x because there's only one x on the inside. Okay. And if I reduce the cube root of -8, that's going to be a -2 cube root of x squared, right? Can't reduce the x squared because, well, there's only 2 x's. And then if I look over here, -9. Now, if you notice how there's 5 x's on the inside, I do have a group of 3, right? If there's 5 of them, I have at least one group of 3. And then on the inside would be 2 left. So if I look at this, I can actually combine. Oh, no, I can't combine these together. If you notice, this is a -2, this is a 9x. I thought maybe I can combine those together, but I can't. But what I am going to do is I am going to distribute. So if I distribute this, 4 times -2 is a -8. Cube root of x times the cube root of x squared is going to be the cube root of x cubed minus 4 times 9 is a 30. Let's write that a little better. Is going to be a 36. X times the cube root of x squared times x is going to give me an x cubed. Let's try to reduce this. So the cube root of x cubed is just x. And then the cube root of x cubed is just x. But there's another x on the outside here. So that's actually going to give me an x squared. Those are not like terms. So this would have to be my final answer. That was a pretty difficult problem. Any assessment that I have would probably not be that. Okay, let's take a look at something that's a little bit more very realistic. For part B, I have 2 radicals that are going to be multiplied together. So I'm going to multiply their outside pieces. 4 times -9 is going to be a -36. And then I'm going to multiply their inside pieces. 3 times 18. I believe, now you can use your calculator here. 3 times the 18 is a 54. And then x times x to the third is going to give me a total of 4 x's under the radical. So the first step is doing the actual multiplication. The second step is going to be now reducing that radical. So if I break this down, 54 is 9 times 6, or I have 3 times 3, and then 6 is 3 times 2 with 1, 2, 3, 4 x's. Now there's already a -36 on the outside, okay? Now if I reduce this radical, I can take out a group of 3's. I can take out actually 2 groups of x's. So what I get here is I'm going to write it off to the side to give myself a little bit more room. A -36 times, now I said I could take a 3 out, I can take out 2 x's, and on the inside, I'm just left with 3 times 2, which is a 6. Combine these together, I believe I get a -108 x squared. Squared is 6, and you are welcome to use your calculator for that to do that multiplication. But that should be my final answer. All right. For part C, You could only combine like terms, but the nice thing for part C is they are already like terms. If you notice, they are all fourth roots, and the inside of those radicals are all just x. So this is like saying 1 fourth root of x plus 8 fourth roots of x minus 7 fourth roots of x. Well, because they're all the same radical, let's start just combining the first two. I'm going to get 9 fourth roots of x minus 7 fourth roots of x, which gives me a 2 fourth roots of x. And that would be my final answer. So that was kind of an easy one. Let's take a look at this next piece. So I have a 15 fifth root of x to the ninth, and over 20, the fifth root of x to the fourth. Now, the way that I did this on my video is I can reduce the 15. Let's get this working here. The 15 over 20, right? We want to reduce that radical. And if I have the fifth root of 1, 2, 3, 4, 5, 6, 7, 8, 9 on the top, and I have the fifth root of 1, 2, 3, 4 on the bottom, if I reduce this fraction, now I can divide both of those by 5. So if you reduce 15 over 20, divide the top by 5 and the bottom by 5. It gives me on the top a 3 over 4. And if I start to reduce these x's, because they are both inside the radicals, you can start canceling them off. I believe I'm left with the fifth root of x to the fifth power. Now, if you look at that, you can reduce that. I have the fifth root of x to the fifth. That should be a red flag because in order to reduce a fifth root, you need groups of 5, but I have a group of 5. I have 5 x's. So this would just become the final answer of 3x over 4. Okay, and that would be my answer. All right, so that is all simplifying, right? So if you go back real quick, this is just reducing a radical. And then I'm going to have you do some problems where we have to add, subtract, multiply, divide different radical expressions. Okay, now the last part of this video is going to be on solving. Okay, this is the last part of cluster target C, but we also have to make sure that we are watching out for extraneous solutions kind of as we go here. So if we do this, let's start with number 15a. I'm going to begin. I want to isolate the radical, the cube root, so I'm going to add 5 to both sides, which gives me a cube root of 4x plus 4 equals 6. Okay, and then I want to get rid of that cube root. I can't get to those 4's under the radical. So if I cube, let's try to do this as neatly as possible here. If I cube both sides, that leaves me everything that was within the radical, and I get 6 cubed. Now you might need a little calculator here. 6 to the third power, I'm pretty sure, I don't have a calculator in front of me, but I'm pretty sure that's 216. I'm going to subtract 4. Let's do this. Why is my pen not working? Okay. There we go. Okay, so if I were to, let's try to fix my pen real quick so we don't have to take these little stops. Okay, so I have a 4x equals, now if you subtract 4, you get 212. Now what I want to do is I want to divide both sides by 4, and that should give me an answer of, let's see, if I divide that, I would, again, probably use a calculator, but I believe I'm going to get 53, okay? So that would be my answer. Now I do need to check that answer though. So if I have the cube root of 4 times 53 plus 4 minus 5, and we want that to equal 1. So again, use your calculators. 4 times 53 is going to be 212 plus 4 minus 5 equals 1. And then 212 plus 4 is 216 minus 5 equals 1. And if you take the cube root of 216, you just get 6 equals 1. And 6 minus 5 is 1 equals 1. That's good. We know that that's solution. So for all of these, not only do you have to solve them, but you have to check your answers. Okay, let's take a look at part B. Part B, we have the radical all by itself. So this was kind of like the last set in the video over this lesson. I want to square both sides. Now, when I square both sides, you have to be very careful because x plus 3 squared means I'm going to take x plus 3 and I'm going to multiply it by itself. I need 2 of them equals. Now, when you square this radical, you are going to end up just using inverse operations. You just get the inside of that radical. So if I do this, x times x is x squared. X times 3 is 3x. 3 times x is another 3x, and 3 times 3 is 9. That gives me 3 minus x. X squared plus 6x plus 9 equals a 3 minus x. Now that I have a quadratic, I want to get all of my terms to one side. I want to get it equal to 0. So if I do that, I'm going to subtract the 3. I also want to add the x. So I'm going to subtract the 3. I'm going to add the x to the left-hand side, which gives me an x squared plus 7x plus 6 equals 0. So what I do now is I factor. All right. And I need to know factors of 6 that add up to 7. So that's, of course, going to be 6 and 1. 1 times 6 is 6. 1 plus 6 is 7. And if you solve that, I think we can all get on the same page here that my two solutions are going to be -6 and -1. Now, I should say preliminary solutions because we need to check those answers, right? So I'm going to start by checking in -6. If I take -6 plus 3, I'm substituting into the original problem. That's going to equal the square root of 3 minus, be very careful with your negatives here, -6. So if I reduce the left-hand side, that's just -3. If I start to reduce the right-hand side, 3 minus -6 is 9. Square root of 9 is just 3. Are those the same? Absolutely not. Those are not the same. Therefore, -6 is extraneous. Okay, we got it as an answer when we started, but when we substitute it back in, it does not work. That is an extraneous solution. All right, so let's check the other one. Let's check -1. So if I have -1 plus 3 equals the square root of 3 minus -1. -1 plus 3 is 2 equals the square root of 3 minus -1. That's going to give me a 4. Square root of 4 is 2. Let's get my stylist working here. There we go. Okay. And that is good. That is going to be our solution. So the only solution we get for this problem is going to be x equal to -1. All right. I think we got 3 more, and then we'll call it quits. Feel free to pause, try to do these. You guys can work through this, but for part C, we have this radical already by itself, so we can go ahead and just get rid of that radical. So what I want to do is if I have, actually we're going to start with a different color here. Let's start with blue. If I have the cube root of 2x plus 7 equals 3, I want to cube both sides, and I get a 2x plus 7 equals, now 3 to the third power is going to be 27. Subtract the 7. I get a 2x equals 20. Divide the 2, and I get, oh, not 2, hold on, mistyping. I get x to be 10. Okay, now we need to check to see if that's a solution. We need to see if it's extraneous. So I'm going to say the cube root of 2 times 10 plus 7 equals 3. So I now have the cube root of 2 times 10 is 20 plus 7 is 27. And if you do this on the calculator, or if you reduce it by hand by breaking it down, the cube root of 27 is in fact 3. That gives you the right answer. Okay, so 10 is our solution. All right, 2 more. So let's take a look at D. If I want to get rid of that radical, so I am going to square both sides, right? So if I take this and I square it, and I take this and I square it, I'm going to be on the left hand, or on the right hand side, I'm just left with the inside of the radical. On the left hand side, I have an x plus 1. I have an x plus 1. I'm going to have to distribute that out. So that gives me a 1x plus a 1x plus a 1 equals 7x plus 15. Let's combine like terms. Okay. Now if I start moving everything to the other side, let's get it equal to 0. We got to solve a quadratic, right? So I now have an x squared minus 5x minus 14 equals 0. So let's see if this factors. So I'm going to say an x minus 7, x plus 2. Excuse me. All right. And that equals 0. So my two solutions are going to be a positive 7 and a negative 2. All right. So I have these two solutions. So we have to check them still. So if I were to take, and I'm going to do this kind of off to the side, and I plug 7 in, 7 plus 1 equals the square root of 7 times 7 plus 15. So let's see what we get here. Excuse me. 7 plus 1 is 8. 7 times 7 is 49 plus 15. So I get 8 equals the square root of 64. And we all know the square root of 64 is just 8. That works. So that is a good solution. But there are times we can have two solutions. So let's check the other one. All right. So if I plug in negative 2 into this one, so let's say negative 2 plus 1 equals the square root of 7 times a negative 2 plus 15. So negative 2 plus 1 is a negative 1. I get a negative 14 plus 15 inside the radical. So negative 1 equals the square root of 1. And the square root of 1 is just 1. That is not true. Therefore, that is, in fact, extraneous. The only good solution to my problem is just x equals 7. All right. So let's take a look at the last question here, part E. Hopefully, I left myself enough room. But we are going to square both sides. So I have an x minus 6. I have an x minus 6 equals 3x. If I distribute, I'm going to get an x squared minus 6x minus 6x plus 36. That's going to equal a 3x. Let's combine like terms. Now, if I subtract 3x over, I have an x squared minus 15x plus 36 equals 0. So let's try to factor that. I think that's going to become an x minus 12, x minus 3. Excuse me. That equals 0. And that gives me the answers of 12 and the answers of 3. Now, if I plug those both in, you are going to get the answer of 12 to be a solution, but the answer of 3 is going to be extraneous. Now, I don't have enough room to show that check, but check it the same way I did all the other ones. If you were to plug 12 in, you should get something like 6 equals 6. If you plug 3 in, you'll get something like -3 equals 3, which is not true. That would end up being an extraneous solution. The only good solution I have is just 12. Okay? So how can you tell if a solution is extraneous? By substituting answers into the original equation. Okay? And when you substitute those answers into the original equation, you need the left-hand side of your equation to equal the right-hand side of your equation. I know that this was a longer video, but I want to put target C all onto the same video so you can kind of fast forward or rewind when needed. All right, thank you.